So vortioxetine, it's a very, very complex medication. Okay. So this is going to be a little, this is a tricky one actually, even for me to explain on a podcast. So we will try to make it as simple as possible. Okay.
Welcome to The Why in Psychiatry,
Hi, this is Dr. Mayo, CEO Fellow,
where we delve into the intricate nuances of psychiatric topics.
My name is Dr. Chandora, attending psychiatrist. I did my residency from University of Connecticut, and then I did my fellowship from Georgetown University in consultation and liaison.
Each episode features interview-style discussions that explore the intersection of the mind, medicine, and the human experience. Together, we'll uncover the hidden why and the groundbreaking discovery shaping the psychiatric landscape. So grab a seat, a warm beverage, tune in, and let's embark on this journey to unlock the mysteries of the human psyche. Only on The Why in Psychiatry.
So, welcome to The Why in Psychiatry. I know for our listeners out there, I do understand that we picked the two guys with the thickest accents to host this podcast. This is progress. And I think the biggest question today will be how to pronounce Vortioxetine. And believe it or not, I went on YouTube and looking, is it Vortioxetine? Vortioxetine? I don't know. That's going to be our challenge for today. Today, we'll be talking about Vortioxetine, why it's unique, what's special about it. And as usual, my co-host, Dr. Andrade, is here with us. Dr. Andrade, Vortioxetine is pretty new even for me. New guy, young guy. So why is it so unique? What's so special about this drug?
So vortioxetine is a newer class of antidepressant.
Is that how you say Vortioxetine?
I say it as vortioxetine. So vortioxetine is unique among the antidepressants because it's not like the typical SSRIs or SNRIs. It will block the serotonin transporter, but it also modulates the functioning of the postsynaptic serotonin receptors. It will definitely affect the presynaptic serotonin receptors, but it's also a modulator of other serotonin receptors. That is what makes it unique among the antidepressant class. Plus, you can also use vortioxetine in patients who have major depressive disorder with cognitive dysfunction. Though it's not FDA approved for the treatment of cognitive dysfunction in depression or in elderly patients with dementia.
Okay. So it's like other SSRI that it blocks the serotonin transporter, so causing an influx of serotonin, but it also affects the receptors itself. It's a modulator of serotonin receptors. So it hits it in a whammy kind of deal. So why is it marketed? It's not the approval. Why is it marketed for cognitive function? What's their claim to say?
The theory behind, right now, nothing is proved, right? We cannot study actually receptor profile in the brain. It's very difficult, basically. Like you can do it, but it's not, we haven't yet reached to that point. So the hypothesis behind vortioxetine improving cognitive functioning is because it increases the level of acetylcholine as well as dopamine in your prefrontal cortex.
Okay.
And that is what helps to improve the cognitive functioning.
How to do that? How does it improve acetylcholine and dopamine in the brain?
So let's talk about the mechanism of action. Like how does vortioxetine works?
Right? That's what I was trying to get to from the beginning, holding out on me. So
it's very complicated, right? The way vortioxetine works is that it blocks the serotonin transporters. Now, usually regular antidepressants, they have to block about 70 to 80% of the serotonin transporter to have the antidepressant effect. But at that particular level, a lot of antidepressants can also cause sexual side effects. Vortioxetine usually blocks about 50% of the serotonin transporters. So that is one advantage that we have. Apart from blocking the serotonin transporter, it also works on the serotonin receptors. Now, before talking about the serotonin receptor, let's talk about the neuronal circuitry in the prefrontal cortex and hippocampus that is most commonly involved in patients with depression. And another point that I want to stress is that the cortex is the one that controls the release of monoamines from the brainstem. Brainstem has three different monoaminergic systems in there. One is locus ceruleus, which releases norepinephrine. The second one is raphe nucleus, which is responsible for serotonin. And then you have the ventral tegmental area for dopamine. So the cortex is not firing well. The pyramidal neurons are not firing efficiently, so there is not enough monoamines that is released. So if you improve the firing of the pyramidal neuron, you can improve the release of these monoamines. And we know that monoaminergic deficiency is one of the theory behind depression. Right? Now, in the prefrontal cortex and in the hippocampus, you have something called GABA interneurons. There are different types, but we are going to put everything together and we'll just say GABA interneuron for simplicity. Now, this GABA interneuron puts a brake on the pyramidal neuron. That means that it fine-tunes the pyramidal neuron, right? So it makes the firing of the pyramidal neuron appropriate or very synchronous. Now, there is a GABA interneuron problem in patients with depression. Now, these GABA internneurons are rich in serotonin receptors. So are the pyramidal neurons. But we're just going to focus on the GABA interneuron. So these GABA interneurons are rich in serotonin receptors. We're going to talk about 3 of them: 5-HT1A, 5-HT1B, and 5-HT3 receptors. 5-HT1A and 1B are autoreceptors. That basically means that if you stimulate them, the cell body, it decreases the firing of the neurons. If you stimulate on the nerve terminal, it decreases the release of the neurotransmitters.
Are they found on both the cell body and the neuroterminal?
The 5-HT, 1B, and 1D are present on the nerve terminals.
On the nerve terminals.
1A is a somatic as well as terminal autoreceptor.
Okay.
But when you block these autoreceptors, it's just the opposite. If they're present in the cell body, it increases the firing. If they're present on nerve terminal, it increases the release of neurotransmitter. Okay. The 5-HT3 receptor is an ionotropic receptor. It's not like a metabotropic receptor like other serotonin receptors. And 5-HT3, when you stimulate them, you increase the firing of the neurons and the release of neurotransmitter. And if you block them, you decrease it. Now, the way vortioxetine works is that it's an agonist at 5-HT1A receptor. So when you stimulate 5-HT1A on the GABA interneuron, you decrease the firing of this GABA interneuron. So you basically disenable the pyramidal neuron. So more firing of the pyramidal neuron, right? Then it's a partial agonist at 5-HT1B. So partial agonist, when you stimulate the 5-HT1B, you decrease the firing of the GABA interneuron, increase the firing of the pyramidal neuron. And we know that the pyramidal neuron is not firing well in patients with depression, right? It's firing lower than normal. And then it also blocks 5-HT3 receptors. So when you block the 5-HT3 receptors, the GABA interneuron decrease the firing. So overall, you're increasing the firing of the pyramidal neuron, which in turn actually stimulates the brainstem, increasing the monoamines. Make sense?
So in depression, there is one of our theories is there's a lack of monoamine neurotransmitters, and that's coming from the brainstem. Now, the pyramidal neurons from the prefrontal cortex tells the brainstem to release monoamines. It does that through the pyramidal neurons. And now there are these GABA interneurons that put a brake on the pyramidal neurons. It's like a chain reaction. GABA interneurons, which is also dysfunctional in depression, but GABA interneurons puts a brake on the pyramidal neurons, and pyramidal neurons then doesn't tell the brainstem to release monoamines. Now, vortioxetine works on these GABA interneurons, and specifically on the 5-HT1A, 5-HT1B, and the 5-HT3 receptors. 5-HT1A is an autoreceptor. And so basically vortioxetine is an agonist on these 2 autoreceptors. And so when it agonizes them or helps them out, leads to less firing of the GABA interneuron. And less firing of the GABA interneurons means more firing of the pyramidal neurons. And then 5-HT3 is an antagonist, which basically does the same, the less firing of the GABA interneurons, more firing of the pyramidal neurons, which leads to more influx of monoamine. Now, you might understand this straight. So not only is there an increase in serotonin, dopamine, and norepinephrine, there's also an increase in acetylcholine as a result of this, which from 1+1 equals B, acetylcholine up means cognitive function up as well. Did I get that right?
You got that absolutely right.
From what I'm getting, so the best time to use and why to use vortioxetine seems like if cognitive issues is part of the depressive symptoms, and then if they're also having sexual side effects.
I want to hit the second part of the mechanism of action of vortioxetine. Because how does it increase the acetylcholine in the prefrontal cortex? So now you have these monoaminergic nerve terminals in your prefrontal cortex, as well as the hippocampus. Now these nerve terminals are from the dopaminergic center, the serotonergic center, and the noradrenergic center, as well as the cholinergic center. The cholinergic center is the basal forebrain. Now, these nerve terminals in the prefrontal cortex and hippocampus are kept under check by these GABA interneurons. So by vortioxetine, by acting on those serotonergic receptor GABA interneuron, it blocks those GABA interneurons. So now these nerve terminals are disinhibited. So now there will be an increase in the level of serotonin, dopamine, norepinephrine, acetylcholine in your prefrontal cortex. That is what improves the cognitive functioning.
I just want to make sure I understand that. So you're saying the acetylcholine hub is not in the brain stem, it's in the basal forebrain. And so even though it disinhibits the pyramidal neurons going to the brain stem, doesn't disinhibit the pyramidal neurons going to the basal forebrain.
So the thing is that these are all interconnected.
Okay.
But the basal forebrain is not the only cholinergic system in the brain. There's cholinergic neurons also present in other areas of brain like pedunculopontine tegmental area, lateral dorsal tegmental, they're different. But the basal forebrain area has nerve terminals that goes into the prefrontal cortex, which is usually blocked by the GABA interneuron. It's afraid. So vortioxetine, by inhibiting the GABA interneuron, disinhibits these nerve terminals.
That's it.
You have more acetylcholine basically in the prefrontal cortex. Because as we said, there's a GABA interneuron dysfunction in depression. So it definitely affects these cholinergic nerve terminals. Make sense?
Yeah, it makes sense. Overall, makes why more influx of these neurotransmitters, including acetylcholine. Like, I think you alluded a little bit to the sexual side effects. Why does it help with sexual side effects?
Now, how does it affect the sexual dysfunction? So vortioxetine is one of the antidepressants that is used when patients develop sexual side effects to other antidepressants. And this is also a board question for people. So according to research data on vortioxetine, the sexual side effect is almost equivalent to placebo, right? Now, most of the antidepressants have to block about 70 to 80% of the serotonin transporters to have an antidepressant effect. That's why trazodone, when you use a small dose, is an hypnotic and is not an antidepressant, because between 25 to 150 milligram, it doesn't cause that much blockage of the serotonin transporters. So when you actually block the serotonin transporters at that high level, you basically develop sexual side effects because you're flooding the system with serotonin, right? On the other hand, vortioxetine doesn't block the serotonin transporter that much, right? It doesn't have to, right? Because it also acts on other serotonin receptors. So because of that, it is more effective in patients who have depression with sexual side effects or who have developed depression. You treated them with SSRI and they develop sexual side effects. Make sense? But again, we do not understand it completely. This is a hypothesis again.
Yeah. And so it's not as potent of a serotonin transporter blocker. And I guess generally in the system, there's not that much higher influx of serotonin. It's because it works on the receptors itself.
It does actually. So if you look at it, its affinity for serotonin transporter is pretty high. Its Ki value is like about 1.6. I don't want to go into that, but it is a very strong affinity for the serotonin transporters.
But doesn't block its other way.
So you don't have to because you have so much effect on other serotonin receptors. It's like atypical antipsychotics. Okay. Like one of the atypical antipsychotics that we use is lumateperone, which doesn't have to block too much of those dopamine because it has effects on the receptor. So I'm not going to go into lumateperone, but what I'm trying to say is that other antidepressants work by blocking the serotonin transporter. Vortioxetine doesn't have to just rely on the serotonin transporters. It can act on the other serotonergic receptors to have the antidepressant effect.
That makes sense. I guess what would you call that? So it has a high affinity for the transporters, but it doesn't block it as much. What's that property called?
What it means is that it's a serotonin transporter, but it's also a serotonin receptor modulator, which is lacking in most of the conventional antidepressants. Other conventional antidepressants just release the serotonin, which then goes and acts on the serotonin receptors. But since this is serotonin, it will have an agonist property on all the serotonin receptors. But vortioxetine is very specialized. It has agonist at one receptor, antagonist at another. So it's very well engineered.
And I think that explains it all. Thank you.
Thank you, Dr. Well.
Thank you for joining us on today's episode. Our tireless team is already hard at work, cobbling together another potpourri of fascinating discussion for next week, so be sure to tune in. Visit our website and our podcast feed and let us know your thoughts on the episode. Subscribe so you don't miss our releases every Wednesday. Until next time, keep smiling, keep shining, and stay curious.